11.1 Angles and circles. Write the equation of the circle with a center at 5, 0 and a radius of 7. So this would be my h and this would be my k, and this is our r. So we've got x minus h, so x minus 5 squared, plus y minus k, which is 0 squared, equals r squared. And then we can simplify this to a nicer answer, x minus 5 squared plus y squared, don't need the 0, equals 49. Graph the circle with the following expanded equation. Well, it's going to be tough to graph it if we don't know what the center and what the radius is, so we're going to need to use completing the square methods in order to convert this from x squared into perfect square trinomials. So let's put our x's together. We've got x squared plus 4x. Then we're going to complete that square, so we'll leave a space, plus y squared plus negative 6y plus the complete of that square equals 23 plus the first plus the second. So just leaving my spaces for my completing the squares. 4 divided by 2 squared is 2 squared, so that's 4. Negative 6 over 2 squared is going to be 3 squared, 9. So then this perfect square trinomial converts to x plus 2 squared. This perfect square trinomial converts to y minus 3 squared. And then 23 plus 4 plus 9 is 36. And now we can clearly see the center and the radius. So the center is at negative 2, positive 3, and our radius is at the square root of 36, which is 6. Now we can graph that, so negative 2, 3 is our center, and then our vertical and horizontal radius, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there's our circle. All right, we're going to learn some vocabulary that goes with circles today. The first vocabulary word is called a central angle. It's an angle inside of a circle with its vertex at the center, or the angle formed by 2 radii. So 2 radius make the central angle. So you have to have a center and then any 2 radius coming out from that. What you need to know is that the central angle, it always comes from the center. So the root word of central is center. Second vocabulary word we're going to learn is called an inscribed angle. I missed the S, sorry. An inscribed angle is inside of a circle, but its vertex is on the circle, and it's formed by 2 chords. So chords don't come from the center, so you can I'll just pick this edge, so it's on the circle. It can go to the same endpoints as your central angle, but the red angle there is called an inscribed angle. It can be much wider than that. It could be an obtuse inscribed angle, so it could just come, really short right there. But as long as it's 2 chords, it creates an inscribed angle. So what is a chord? I hear kids want to pronounce that chord. It's not a chord, it's a chord. You don't pronounce the H. It's a segment inside of a circle with its endpoints on the circle. So for example, a chord could be that. It can go across. It just, even a diameter can be a chord. A diameter is a special chord. It's one that goes through the center. And finally, our last vocabulary word is called a tangent. A tangent is on the same plane as a circle, and it's a segment that only intersects the circle at one point. So for example, if I draw one point right there, a segment touches that circle at exactly one point. It's not touching it at multiple points, it's only touching it at one. So this is a point of tangency, and this line is tangent to the circle. All right, some of the mathematical features. An inscribed angle, so this is my red angle here. An inscribed angle is half the measure of its central angle. So if this is 50 degrees, then this measure is 25 degrees. So inscribed angles are half the measure of its central angle. So taking a look at a special example of an inscribed angle, if we look at this inscribed angle, PRUS, its endpoints are right here at the diameter. If that's the case, then this top half of the circle is going to be 180 degrees, which means that this angle is half, which means that angle is 90 degrees. So RS is a diameter. It's a chord that goes through the center. And diameters make, with their inscribed angle, always make a right triangle. All right, some more vocabulary words. The tangent theorem. A tangent theorem is a line, ray, or segment is tangent to a circle if and only if in the same plane as the circle and is perpendicular to the radius or diameter of the circle at the point of tangency. So we can say that this line is tangent if and only if we know that that is a 90-degree angle from the radius or diameter if you had the full segment. But if you just have the radius, it still needs to be perpendicular or a 90-degree angle to be tangent. Few more vocabulary words. An arc is an unbroken part of a circle. So an arc can have two different things. An arc can have a measure, which is going to be a degree. And an arc can also have a length, which is the part of a circumference. So there's two different things. We're mostly going to be talking about the measure of arcs, which has to do with its degree measure. But sometimes we're going to actually say what is the length of that. And you actually have to know what the circumference is in order to calculate that length. So just make sure that you keep those two things different. So an arc measure is degree and an arc length is an actual length of the circumference. So let's talk about a minor arc. Minor arcs are less than a semicircle, so less than a half circle. A really good example of that would be BC. And what you do is you do an arc symbol above it. So B to C is a minor arc. C to D would be another example of a minor arc. So it's just got to be less than a semicircle. A major arc is something that's greater than a semicircle, and you write it with 3 letters because you're going further than the minor arc. So for example, if I start at C and I go to B and then I come all the way around to D, that would be a major arc. So CBD is a major arc. A semicircle is a half of the circle. You still use 3 letters to denote it, so that would be B to A to D. Or you can go B to C to D. Would be examples. You can even go the other direction. You could say D to C to B, as long as you, it doesn't really matter what order you write the letters in, as long as it represents the 3 letters on the semicircle length. So now let's label some parts of this. If this central angle is 30 degrees, its arc measure is also 30 degrees. If D to B is a semicircle, 180 minus 30 gives me 150 degrees for C to D, which means its central angle is 150 degrees. And then we know B to A to D is a semicircle, so this line here is 180 degrees, and this part of the arc measure is also 180 degrees. So 180 plus 180 is 360, so we've got all the measures of the whole circle. The measure of an arc is the measure of its central angle. We just showed that from above. If this is 30 degrees, then this is 30 degrees. Central angles match their arc measure. Now we're going to learn a few mathematical tools for inscribed angles. Central angles are really straightforward since they're the same measure. Inscribed angles have a couple of different theorems that come with it. So number one, the measure of an inscribed angle is half the measure of its intercepted arc. So for example, if I draw an inscribed angle, and I said that this arc measure was 50 degrees from A to B, then this angle here would be 25. Number two, inscribed angles that intercept the same arc are congruent. So if I draw A, B, and I draw one inscribed angle that goes to AB over there, but I also draw one over here that lands on AB, I know that these two angles are congruent because they share arc AB. Finally, the measure of an angle formed by a tangent and a chord is half the measure of its intercepted arc. So let's draw a chord. And then let's draw a segment tangent at point A. So this angle here, from my red line to my purple line, that angle, let's call that angle number 1. Mathematically, we can say the measure of angle 1 is going to be equal to 1/2 the measure of arc AB. So if I know this measure of arc AB to be, I don't know, 200 degrees, then we know that the measure of angle 1 would be 100 degrees. It's half the measure of its intercepted arc. So now we're going to apply these techniques to this example. We'd like to use our inscribed angles. So it says use the figure to the right to find each measure. Give the number of which inscribed angle theorem you used, 1, 2, or 3, to find each measure. Give the reason below. So letter A says find the measure of BD. So we'd like to know BD. I can see that its corresponding inscribed angle is 21 degrees. So their relationship is half or double. So I know that BD is 42 degrees. And that was based off of this basic understanding number 1. Now we'd like the measure of BFD. BFD. Well, BFD is corresponding to arc measure 42, which means that that angle is also 21 degrees. And we also used the BFD, we used the number 1 again for that guy. Well, it's also number 2 because they're shared, because they share BD. All right, angle BCD. BCD is a central angle. It comes from the center, and it matches 42. So that angle measure is also 42 because it's a central angle. And then we'd also like to know the measure of arc AF. If this is 42, then this angle is also 42, which means that AF is also 42, using central angle knowledge. This 21 degrees is this angle right here. I know I squeezed it in there. All right, we'd like to know what is the measure of arc FBD. FBD, oh, that goes all the way around from a diameter, so it's 180 degrees. It's a semicircle. And we also like to know what is the measure of AB. Well, if this is 42, then this is 42. That whole length is 180, so 180 minus 2 times 42 leaves us with 96 degrees. And the last angle we'd like to know is FBG. FBG, so this angle here, is going to be half of its intercepted arc. So that's from B all the way to F. So 96 plus 42 cut in half. Or we can write it like this, 1/2 96 plus 42, which is 69 degrees. And we used the number 3 inscribed angles theorem. Thank you.